Okay, in this video we're going to look at some examples of finding the orders of some elements modulo n. So let's recall that the order of A mod n is the smallest number m, and we take m to be a natural number, such that A to the m is congruent to 1 mod n. And then we have this important fact, which we proved in a previous video, that the order of a number modulo n must divide phi of n, where that is Euler's phi function or Euler's totient function. So we want to look at some examples. And so let's first look at the order mod 7 of 2. So let's look at that. So the first thing that we're going to use is this very important fact to calculate the possible orders. So the possible orders are divisors of phi of 7, which equals 6, right? Because the order must divide phi of 7. So that tells us that the possible orders are 1, 2, 3, and 6. Okay, great. So now we just need to check each of these numbers until we have discovered which one is the right order. So let's do 2 to the 1, which equals 2. So that's obviously not equal to 1. 2 squared is equal to 4. That's obviously not equal to 1 mod 7. 2 cubed equals 8, which is congruent to 1 mod 7. So that means we're done. The answer here is 3. The order of 2 mod 7 is 3. Okay, good. So let's do another example. So let's calculate, in this case, the order mod 30 of 7. Okay, good. So our possible orders, we're going to do the same thing. So the possible orders must divide phi of 30. So I have a video where I make a formula for the Euler phi function. So it goes something like this. So it's 30 times 1 minus the reciprocal of all of the prime factors. So our prime factors here are 2, 3, and 5. So that means I have 30, and then 1 minus half, 1 minus third, 1 minus fifth. And so in this case, we get 8. Okay, so that tells us that the possible orders are in the following set: 1, 2, 4, and 8. Okay, great. So the next thing we can do is raise 7 to each of these exponents and find out what it takes to bring us back to 1. So 7 to the first power is obviously 7. So, kind of as a spoiler alert, the only thing with order 1 will be 1 itself. And then 7 squared is equal to 49. So 49 is equal to 19. And so 19 is further than halfway between 1 and 30. So I would maybe like to write that as negative 11 mod 30, so we're working mod 30 here. Now the next one we have to look at, we don't need to look at 7 cubed because that's not a divisor of 8. So we need to look at 7 to the 4th. So we'll look at 7 to the 4th, which we can use that trick is 7 squared, which will be negative 11 squared. So negative 11 squared is the same thing as 11 squared, which is 121. And then 121 is obviously 120 plus 1. So that is congruent to 1 mod 30. So we have calculated this. The order of 7 mod 30 is equal to 4. Okay, good. So that's the end of this video, and we'll pick back up with a couple more propositions relating to the order of elements.